So this is the second numerical that we are considering for PAL. We have already solved the first question of PAL that was having the three outputs. Now we will see if you are having a single expression like F. Here they have mentioned ABC is my input, and they have given in terms of SOP. This is 0, 1, 3, 5, and 7. For example, this is the question numerical, and we have to implement by using the PAL. So as you know, we have to know the 5 step. First, draw the truth table. Second step is finding the minimal SOP form, minimal SOP form that you can either use. You can use either K-map or the theorems. And in third step, we need to find out the number of input buffers. In the fourth step, we need to find out number of programmable AND gates. And in the fifth step, we need to find out the number of fixed OR gate. Because in PAL, we have a fixed OR gate, whereas in PLA, we are having the programmable OR gate. Now, as we are having this expression of F, first, I'm writing F is F A B C, and the expression that we are having is in the terms of SOP 0, 1, 3, 5, 7. So first we have to draw this truth table. So here we are considering ABC is my input variables and F is my output. As we are having the 3 inputs, we can have a maximum of 8 possible combinations. So I'm drawing all the 8 possible combinations here like this: 0, 0, 1, 1, 0, 0, 1, 1. Similarly, 0, 1, 0, 1, 0, 1, 0, 1. Now here F is 1. What is the meaning of this symbol? It is indicating SOP. That means the function value will be 1 for these minterms. And what is the minterm here? Minterm is the decimal representation of this binary combination. So this is 0, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, and this is 7. Right. For these, for 0, 1, 3, 5, 7, the function value will be 1. So 0 is 1 because 0, 0, 0, 1 is 1. That's also 1. But 2 is 0. 2 is 0. 3 is 1. 3 is 1. We don't have 4. 4 is 0. If 5 is present, that means it's 1. 6 is not there, that means 0. And 7 is there, that means 1. So this is the complete truth table for this numerical. Here. Now we will see the another step to solve the PAL, that is minimal SOP. For minimal SOP, you can either use the theorems or you can use the K-map. If, for example, here in this case, I'm using the K-map. Okay, how many inputs are there? 3 inputs. So we will have a 3 variable K-map. Here I'm considering A, here I'm considering BC. We have only one output, that is F. So for F only, I'm drawing the K-map. As the K-map follows the gray code 0, 0, 0, 1, 1, 1, and 1, 0. As this is following the gray code, we have to write down like this. This is the min term 0, 1, 3, 2, 4, 5, 7, and 6. Now we have to fill the K-map by 1 wherever your function value is there, like 0, 1. So 0 is this one. So we have to fill it here. 0, 1, then 2 is 0, then 3 is there. So 3 is 1. Then 5 and 7. Sorry, 0, 3. 0, 3. Okay, sorry. So 0, 3, and 5 and 7. So this many terms we have in the K-map. Now we have to make the combination. So always think about the bigger group. If there is a possibility of making the quad, always make a quad first. And another one, we can make a pair like this. So this is the 2 group possible in this K-map. And the expression from the quad I will get is C. And from this pair, I will get what? A bar, B bar. So finally, I can write down the minimal SOP form of F as A bar B bar plus C. So this is the third step where we have calculated the minimal SOP form. Now in the third step, we need to find out the number of input buffers. How many input buffer we require? The number of input buffer required is the number of inputs. And we are having the 3 inputs, right? What are that? The name are A, B, and C. Now in the fourth step, we have to find out the number of programmable AND gate, number of programmable AND gate. And here, if you see the expression of F, that is given by A bar B bar plus C. As here we have single output and the number of minterms are 2, right? So, and we have a single output, so it's 2 multiplied with 1. This is the number of minterms maximum. Okay, this is the maximum number of minterms multiply with number of output. So that will be the number of programmable AND gates. So the maximum number, as we are having only a single output and the number of minterms are 2. So that is actually the maximum number of minterms, and the number of output, we have a single output, so it's 1. So 2 cross 1. So that means the number of programmable AND gate we require is 2. Now similarly, we have to find out the number of fixed OR gate. The number of fixed OR gate will be equals to the number of output, and here we have a single output, that is F. So we require a single OR gate. Now we have followed all the 5 steps that is required to design the PL. Draw the truth table, minimal SOP, number of input buffer, number of programmable AND gate, and number of fixed OR gate. We already calculated. Now we will use these 5 values to implement the circuit. Always you start with a buffer. So as we are required 3 buffer, I am using it here. 1 buffer for A, 1 buffer for B, and 1 buffer for C. Like this. And as you know, in the buffer, we have 2 terminal. One terminal will give you a direct normal form of A. Another terminal will give you the complement form. Similarly, here also normal form, and this is the complement form. This is the normal form, and this is the complement form of C. And how many AND gate we have seen? In the calculation, we have seen we require 2. We require 2 AND gates. So we have to draw the 2 AND gate here. So for one, I'm drawing it like this. This is one AND gate. Another AND gate is like this. Now we have to extend little more to include the OR gate also. And we are having only a one fixed OR gate. That's why we have drawn. And this is your F. Now, if you see the expression of the Y, F, that is A bar B bar plus C. So this is A bar B bar. This is A bar B bar. Why I'm making crosses here? Because it's a programmable. Similarly, C, A bar B bar plus C. So C is this one. So I am making it as a cross because AND gate is programmable here. That's why we are making it cross. And here, this is the fixed connection. So that's you have OR gate are fixed connection. So you have to make it by the bubble. Thank you.